Hey, I'm Kerm. Welcome back to the Build a Basement. Today we're going to be doing some bed work, meaning that we're going to prep our Mandela Roseworks bed. Now, these beds are awesome. They're expensive, but I think they're well worth it. So let's jump right into it. All right, so today we're going to go ahead and get some stuff done here with the bed. We're going to do some pre-prepping of the bed to get ready to put in the printer. And the bed I'm using isn't the bed that normally comes in the kit. And I have reasons for that, and I'll explain them real quickly here. Number one, this is a Mandela Roseworks bed. These are not rolled, these are machine beds, which means that when heat's applied to the bed, and they're cooled and they heat up, it's gonna happen every time you print. You're gonna heat up the bed, you're gonna cool off the bed, heat up the bed, cool off the bed. It's not gonna deform like a rolled bed would, because when you roll out metal, you cause that material, that metal, to actually have areas where it's under tension, under stress, because of that process of rolling it out. When you cast a piece of metal and you allow basically all those molecules to kind of rest where they are, they're completely at ease and they just solidify where they stand, and then you machine out to the flat surface that you need, you're not causing stresses to that metal internally, so that when they heat up and cool off, that they'll start to move around. Everything stays at rest. So it's a little bit more money, but they are very nice. They're very flat, and this one in particular has the neodymium magnets in it, which afford me the ability to not put a magnetic, basically a magnetic sheet on this. Now, you can get these without the magnets in them, but I would say it's not worth it. Personal opinion. If you're going to go to the expense of getting one of these beds, for the flatness, the quality of the bed, you may as well get the magnets in it as well, because as soon as you put a magnetic sheet on a bed, your bed's only, or the surface that you put on top of that's only going to be as flat as whatever's underneath it, meaning that the magnet, the sheet magnet you're putting on this, is never going to be as flat as the aluminum surface that you're mounting it to. They're just, they're meant to be flat, but they're not meant to be flat to the nth degree. So, yeah, Mandela Rosework machine bed, nice and flat with the magnets in it. What I think is a perfect combo. So we're not going to be putting the magnetic sheet on here, but the magnetic sheet goes on in much the same way as the heater. Now the heater, this guy right here, this is a Kenovo, 120 volt. If you're someplace where you utilize 220, 240, you'll have that as opposed to this, 500 watts. And simple math will tell you that basically, this is gonna suck down quite a bit of power. So you're looking at about roughly 5 amps here. So you divide the 500 by the 120. It's less than 5, it's actually, but 4.05, somewhere in that range. Anyway, 4.1. So anyways, that's the amount of amperage that's going to draw on this, and that plays into everything because people wonder where all the power is inside the printer. This is the primary suck of power into the printer. Roughly a 5 amp draw here, roughly a 2 amp draw or 1 amp draw at the nozzle. There you go. You have 6 amps going on, another amp there. So a printer this size, a 300mm printer, is going to take roughly 7 amps power when everything's on, but it's not always on all the time. So prep. Let's look here at the manual and talk a little bit about the printer bed and talk about where the holes are in the bed to kind of associate or get this associated with how it's going to be inside the printer, as in where the back, top, front, all those sides are. Now, on this particular bed, I know for a 100% fact, without even looking at anything, that this is the top of the bed because this is where the magnets are. Now, if you have a bed that doesn't have embedded magnets, and most of them don't, unless you get it from Mandela again, you'll have to basically follow along and pay attention to that as well. In our case, we're looking pretty much here to see where the primary screw holes are. They're going to hold this bed to the printer itself. So 2 in the front, 1 in the rear. There's nothing here, so we know that this right here is the front of our printer. based on the fact that we show one here, and one here. There are additional ancillary holes cut out. These ones that we see here, these 9 holes right here, are all for the screws and the magnets. This one here in the center is mounting point. These additional ones here are for other setups and also for mounting additional things that we're going to mount to this printer, such as our thermistor. So this is the back, this is the front, it's facing towards me. Which side is which? This plate has mounting holes. Basically talking about the fact that the mounting holes are kind of embedded there a little bit. They kind of have a little additional bore on them so that the screws will sit flush with the printer top when you get to that point. So that's how you're going to tell if you don't have a bed like this. So yeah. Let's see, they're talking about the magnetic sheet here. Like I said, we're not putting the magnetic sheet on this particular build, but the magnetic sheet goes on pretty much exactly how the bed heater goes on here. So if you follow along and you're doing the magnetic sheet, just watch the video, and that's going on the same way as this heater does. So I'm going to skip over that. Heater application. So front to back. So I'm going to flip this around here, so we're trying to stay with the same approximate to the picture that we're looking at. And the reason why we got to do that is there are wires that are on our heater. Now, obviously there are wires to actually heat the printer, but there's also wires to do other things here. So the 2 thin wires on here that go to this device right here, this is actually a thermistor that's embedded in some high temp silicone. And right here is the junction point for the actual heater to heat up this. Now inside of this fiberglass silicone device, basically you have a thin resistive core of wire that goes back and forth to basically create a large resistive load that heats up when you apply electricity to it. So as it heats up, it heats itself up and then heats up the surface it's attached to, which is our bed. It's pretty simple, but the reason I mention that is because you don't want to cut places on here. You can possibly get away with trimming some areas of this a little bit, but frankly, I don't know how much you can get away with. So I'm going to tell you not to cut this if you can get away with it whatsoever from not doing that. Which is going to be tricky because we're going to be using some RTV silicone, some high temp gasket maker to basically add another layer of security to this. And we're going to have to be very careful when we do that because I don't want to get it all over the place. And as you can see, we have some limited spaces here to put that. So let's see what it says. They talk about mounting thermistor, stuff like that. So let's look at prep. So this is a 3M backing material here with a 3M glue behind it. But to ensure we get the best possible glue surface here, the first thing I like to do is use some isopropyl alcohol, preferably a 91-93% or higher, and a lint-free cloth, and just give it a good wipe down. It's kind of step one. Rid of any machining oils and things like that that might be on there. The next thing I like to do is actually rough it up a little bit, which sounds kind of odd, but this is a surface that glue is going to stick into. And if you think about it on a microscopic level, if you have a flat surface, which this isn't perfectly flat, but it's pretty flat, there's not a lot of additional surface area. So if we cut little scratches into that surface, we're going to make additional surface area. You can double the amount of surface area really quickly on something like this, and the glue will just flow into that a little bit. Now, you can use a Scotch-Brite pad like this, and it will work just fine, and it will provide you with a decent surface. Or you can use something like a 220. I wouldn't use anything lower than a 220, like not a 180, not a 100, but maybe a 220 or 240 or even maybe a 320, but that'd be pushing it to do the same thing. So this might be a little loud, but I'm going to go ahead and do this real quick. I'm just going to do a circular motion on this. And I want to really make sure I get it near the edges, because if this starts to lift, it's going to lift from the edges more than likely, and that's going to cause it to peel. So make sure we get it good and all over, and definitely on the edge areas where that's going to be going onto this. I'll also say that aluminum dust isn't awesome to breathe in, so you might want to wear a respirator if you're concerned about that, or if you're doing this a lot, or yeah. So one thing you can do is you can put a little bit of isopropyl alcohol down when you are sanding. That'll help keep any of that dust down. Something like that. Now we have a slightly roughed up surface here. I'm sure to some extent Bella Roseworks, if they see this video, is going to be cringing if they see me doing that to the bed, because they put a lot of effort in these. Make them nice. There we go. I want to do it, so I'm going to say it. Stay away. There's a temptation to touch this to see what it feels like, because, you know, obviously this looks different than it did originally. But when you touch this, no matter how clean your hands are, you're going to leave surface oils on there. So do not touch the surface once you've prepped it. For prepping, that's good. I'm going to call that good for now. We're again confirm our orientation with our two holes up here, single hole back here, wires heading towards the back, front, back, single like that. And what I'm going to do is line things up. And in order to line things up, I strongly suggest you kind of eyeball a couple things. Number one being your thermistor. Make sure that there is indeed enough room to mount that in the hole that you're going to mount in. The 5mm and a 3mm. Like that. You're also going to have a ground you're going to put on here, so you want to make sure you have plenty of room for that as well. This looks pretty good. Look to make sure things are relatively equal all the way around. And I'm just going to eyeball this because it's not hugely important. But now I'm going to take a piece of tape, now that I like where it is. I'm going to tape this down and try not to tape it to the flat surface of the aluminum, but rather down to my table and to the edge. And this is just to hold this so it doesn't move from the position it's in. It's not here to actually hold it down at all. So what I like to do is lift this up just a little bit and then basically start to peel back this backer. And if it breaks, it's okay. Just grab it again. And you really don't want to pull back on too much of it. You just want to get it started. You just want to have kind of an edge here. Makes it was all one piece, but there we go. All right, so I'm going to do that about 1/3. I'm going to leave that paper back there like that to hold things in place. But we've also kind of lost our tape spot here, so I'm going to readjust that. Make sure we're still good everywhere. And I'm going to simply apply a little bit of pressure to this front portion of this. Now, a lot of people use rollers and things like that, and you feel free to do that. But your fingers will work just as well for this type of thing. We're not putting on a vinyl sticker. We are trying to make sure that there's no air bubbles, but this is relatively thick, so I do believe that using a roller would possibly be better, but I don't think it's necessary because of the thickness of it. So I'm going to do that like that. And then one other tip that you can do if you choose to, I don't, because as soon as you use the bed for the first time, I think you get the same effect, but that's to go ahead and heat up the adhesive on the heater or to heat up the bed slightly. Basically the hot glue will work better and adhere better when it's hot versus when it's cold like this, but it's a heater, so it's going to heat itself up, so limited mileage on that one. So, all right, so now we have that first couple inches done, or around 5 centimeters or so. I'm going to pull this back another couple inches or a few more centimeters, and I'm going to work this down the middle a little bit and be careful around my thermistor. And I'm going to kind of work in a down and out pattern. What I'm trying to do is ensure that we have as little as possible air behind this. Kind of down and out. Do that again. A little bit at a time. Again, down and out. What I'm doing is I'm pushing everything out the closest exit. And I'm trying not to pick blocks. So if you push down the sides first when you're doing this, you say do this and then you start pushing, you've eliminated the ability for air to be processed through the sides. It's only going to be able to come up this way. So if you work kind of, in a not a radial pattern, but a side with a downwards motion here, you kind of give everything a way to work its way out, kind of like a wave. So do this again. Now we're down about here. I'll also say you could probably slap this right on, take the whole back off of it, put it right on there, and probably be happy forever. But you might not be, so you choose. Building one of these printers is definitely one of those things where a little bit of effort in the beginning, when you're building the printer, or as you're building the printer, tend to pay off in the end. Less maintenance, less issues, less headaches. Gotta put this edge over here. Finally, I'm gonna do a final pull out here. And that should be pretty well adhered. Now, again, with the heat, I've seen even people go ahead and even hook this up to mains power, because basically this is running AC power. You could put a plug on this and plug it into a wall, and it will just produce 500 watts of heat pretty quickly. You'll probably heat this up to a few hundred degrees in a relatively short time. I would not do that. You don't need to do that, and don't zap yourself. Be careful. So just in case that thought pops in. So now we have this adhered to the bed, and it looks good, and definitely no bubbles in that. What my next task is to put our additional insurance on here. The additional insurance is to run a bead of RTV silicone around the perimeter here, so if the glue comes off, because the glue is good to between 135 and 150 Celsius. If that delaminates or comes off because it got too hot, the RTV silicone will still hold the heater to the bed, not allow the bed or the heater on the bed to just slop off and be on the bottom of the printer. So this is ultra red gasket maker high temp. It basically any high temp silicone will work pretty well. This is a decent brand. This is Permatex. A tube like this costs a few bucks, probably about $8. So it's also cheap insurance. So we're going to take the cap off, use the back of the cap to put a hole in here. We'll put the end on, and then we're going to get something sharp. It can be a knife or a cut-off tool of some sort. I'm just going to cut a decently sized portion off of that. I'm going to bring back our little 3M paper here. I'm going to push this from the bottom so we're not wasting it. Just going to work that up the tube. A lot like toothpaste. It's thicker. There we go. There. This stuff takes about anywhere from about 12 to 24 hours to dry, so keep that in mind as well. So I know I'm putting on, I'm going to use the 5mm holes here for my thermistor and a 5mm hole for my ground that's going to go on here. So I'm going to leave that area free. I also know that we have mounting points here. Actually, apologize, ground thermistor back here. So pretty much the areas where we're going to be mounting things to it, because we don't have a lot of extra room, I'm going to leave without the RTV. I did print off some tools to use to be able to help us out here. These little things here. I'll try to put a link in the description for those, but just printed spatulas, more or less. So, application, and I'm no pro at this. It's not hugely difficult, but basically just take your time. And you're going to want to try to hold it pretty straight. And some people like to put masking tape around. I find it doesn't really help me. So it's a little bit there. And what you want is you want a decent span of it to go over your actual heater. And you also want it to be touching your metal. So something like that's not too bad. That. Once this is all dried up, you can also come back and you can use a razor blade to clean up that edge. It'll cut off. So let's go ahead and get the rest of this done, and then we'll clean it up a little bit. Alright, so I'm sure there are plenty of people that can do a lot better than I did, but I'm also sure there are plenty of people that have done a lot worse than I just did. So keep that when you're doing it. Neatness does count, but anything that gets over on the edges, you can clean off using a razor blade when the time comes. Try not to make too much of a mess. Try to get a feel for it first. Maybe do a small strip of maybe 4 or 6 inches. 10 centimeters or so. And that's what you should wind up. So now we've got to let this kind of sit here for a good while. This actually has to dry for a long while. What does it say here? I'm not going to read that, but a good minimum 8-10 hours, maybe 12, depending on humidity and those types of things, temperature. 24 hours for a kind of a cure. But it doesn't have to be cured for us to continue on with the print, but you want to do this maybe the night before that you move on to do the next steps, which are going to be mount the thermistor and do some other stuff here, which we're looking at right here. So they're saying use an M3x8. This particular bed here allows us to use 5 or 3s, and then we'll get this done.